Sujay, can you repeat once again for that yesterday's class?
Yeah, no issue. So tomorrow we can do that. So today we are going to do the introduction to big data. Okay. So these are the 19 people who are going to join the class. So this happens. The people want course, videos and everything, but they're not going to join the class. And I want to become data scientist and all the stuff like this. No issues, guys. So we'll start the class. So we're not bothered about anyone. So in this class, in these people who have joined, so like anyone attended the introduction to big data previously? Anyone in this group, 21 people, did you attend the introduction to that big data previously?
No, I missed that class.
Okay, nice. No. Okay. No issues, guys. So everyone is ready? So there are like 23 people in the class right now. So everyone is ready? 22 maybe. So just wait for 2 more minutes and we'll just start the class, guys. So just wait for the people to join.
Hello.
Yeah, please.
Yeah, sorry. I was just checking whether I'm still there in the call. I left through my phone and I'm there through my laptop now.
Yeah, no issues.
Okay, I'm still there.
Unmuted.
Yeah, please. Sorry. Can you be loud? Like I can't able to hear your voice. So run unif is nothing but it's going to generate random 100 like random values. So if you say run if 100, then it's going to generate 100 random values in a like a random uniform manner like that. So it's like I'm going to discuss about that in future classes. So what is the random distribution, what is the normal distribution, all that stuff. So at that time we can able to get the things. But here until this point, what should we know that? So whenever you say R unif of 100, so it's going to generate 100 random values. And whenever you say R norm of 100, it's going to generate 100 values. Okay, so 100 random values. So if you want to generate a random value, suppose say I just want to generate 10 random values, so I can use either or norm or either I can use or unif right now. Okay, so just that keep in that mind, that's it. So if you want to generate 100 random values, just use runif or norm function for that. Okay, so just only keep that in mind. There is no other things like that. So we're going to discuss about that normal distribution, all this stuff in next future classes. So at that time we can able to get the things. Okay. Okay, as we start the class then. Yeah. So it's okay. Like people are not joining back, no issues. So we'll start the class. So today we are going to discuss about the like introduction to big data. Okay. So what is basically big data? So why big data? What are the problems which are present in the big data? And what are the solutions that come up with like that? Okay. So various things about this big data and all this stuff. So I just open my notepad. So whenever someone says you big data, so what's gonna come into your mind? So guys, so whenever someone says you big data, so what is going to come into your minds? Anyone? So so when someone says you it's a big data, so what's going to come into your mind?
It's a large volumes of data.
Yeah, yeah, it's correct. And any other things?
Mainly for unstructured data.
Hmm. Very big amount of data like Google and Amazon. Okay, so that's also correct. And any others?
Maybe it's a variety of data.
Yeah, we can also say it a variety of data. Yeah, next thing. Okay, guys. So whenever someone says me, so big data. So what thing comes into my mind is, so I just say it as a problem. Okay. So whenever someone says me, it's big data. So I just think that so it's a problem actually. Okay. So why I think the big data is a problem and why I think like that, I just give a clarity. So so when someone says you big data, okay, the main thing which comes into my mind is basically a problem. So big data is basically a big problem. Sorry, sir. Thank you very much.
This conference will now be recorded.
So hi guys. So we are discussing about big data. So when someone says big data, so what thing comes into my mind is, so I tell big data is a problem. Okay. So I say like whenever someone says big data, so I say it's a problem. Okay. And so what are the problems actually? So which are present in the big data is, so we have a huge amount of data, right? So there is a problem with our storage. So we have huge data and we are nothing we are lack of storage devices for that. Okay. And next thing which comes into my mind is processing. Okay. So the storage is the first difficulty. And suppose I have stored some way. So you have like TBs of data, and you have sorted it out some way, and you have stored it into your databases. Okay. And the next challenge which comes after storing the data is processing. So once we store the data, so suppose say if you want to get the data, so I just want the details of a student, so I just want to get that data. So we have TBs of data, and we are not limited to one device. So we are going to store the data in various devices. So the one device can't hold your this huge data. So we have various number of devices at various places with a huge amount of data. And if you want to retrieve one information, so it's going to be a problem. So it's going to challenge for us, right? So we have huge amount of data, and if you want to get one thing, so it's going to be challenge. The first major problem, so where we can't able to store the data first. Okay, the storage is a major problem. Suppose we have some way we sorted out that problem and we stored the data, and the next problem which comes into our scenario is processing. So suppose say I just want the student details of Sujay from the database. So it's gonna be challenge, right? So we have huge amount of data, and how to find the Sujay data in this huge amount of data. Okay, so both problems. So big data is nothing but it's a both problems. So storage is a problem and processing is a problem. Okay, so that's why. So big data is nothing but huge amount of data. But whenever someone says me big data, I just say it's a problem. And what are the problems? Storage and as well as processing the data. Okay. So we have different things here. So storage has three different properties. So when someone says you big data, so the people say in this way. So we have 6 V's for that. Okay. So 6 V's are going to describe you about the big data. Okay. So when coming to the storage, the properties of the storage is volume, variety, and veracity. Okay. And so what is the what is the meaning of this? So when coming to the storage, so we have three different problems here. So volume, so V for volume, so volume is going to be one problem for us. Variety, so we have different type of data present in the real world, so it's huge varieties of data, so that's one major problem. And then after veracity, which is nothing but accuracy. So whenever you want to retrieve the data after storage, so we can't say what data we are going to get accurately. Okay, why? Because we have huge amount of data, and whenever we retrieve the data, so we are not assured that it's going to get the correct output or not. Okay, so that's the thing. So internally while discussing, so what's volume actually? So we have different amount of volumes right now in the market. So coming from kbs, so kb is the basic level. So coming from bytes. Okay, so byte is the basic level. Next kilobyte, megabyte, MB, GB, and next TB, and next like that we have so much of data. Okay, so they have is a measure for data, MB, KB, GB, TB, like that. Okay, so we have different volumes of data, and it's very hard to store this much huge amount of data into the databases. Okay, so suppose say so what is the big data? So suppose say if it is the data is 1000 GB, then we can say it's a big data. Or when, if data is suppose say 1 TB, so we can say it a big data or not. Can you tell me? So suppose say someone says you, so I have 1 TB of data. So can you say that is it a big data or not? Or something like 1000 TB of data. So when someone says you have 1000 TB of data, so can you figure it out? So is it a big data or not? So can anyone tell me the answer for this? So when someone says you, I have 1000 TBs of data with me. So according to you, is it a big data or not? Anyone? Guys, it's yeah, it's a big data according to Nitesh. No idea. Okay, no issues. No, it's
Yes,
not a
we
big
can
data.
consider it as a big data.
Okay. So according to you, it's a big data. Any other answers, guys? Maybe more than that. So suppose I have 1000 TB. You think that's not going to be a big data? Okay, so fine. So when someone says you a TB, so suppose I am not talking about TBs. So I'll just say suppose I have 8 GB of data. So I can say that 8 GB is a big data to me. So how? So can you guys agree with this? So I have 4 TB of data with me. I can say it's a big data for me. So do you guys agree?
No.
Yes. Okay. So whenever I have a 4 GB of data, or suppose I just have 4 KB of data. So can you say that it's a big data or not for me? According to me, no. Okay. But unfortunately, the answer is yes. Okay. So unfortunately, the answer is yes. So it depends actually. Correct. So suppose say I have 4 GB of I have 5 GB of data. Okay, with me, and I only have the 3 GB of pen drive with me. Okay, so I have 5 GB of data, but have pen drive which is capable of storing only 3 GB. Okay, so then I can say that it's big data to me. Why? Because I'm having 3 GB capacity, but the actual data is 5 GB. So then at that time I can say that 3 GB is a big data to me. Okay, like that. So like whenever I have 5 GB of data with me, so I just want to store it. So I have only 3 GB pen drive with me. So at that time I can say this 5 GB of data is a big data to me. Why? Because my 3 GB data can't store the whole data into that. Okay, so it's a big data to my 3 GB pen drive. Okay, so did you guys understand this? So like I have 5 GB pen drive with me. So sorry, I have 5 GB data with me, but I have only 3 GB of pen drive. So 3 GB of pen drive with me. So I can't store the 5 GB of data into the 3 GB pen drive, right? So I can say the 5 GB data is a big data to my 3 GB pen drive. So guys agree? Yes. So say similar, I just say it in normal layman example. So I have a 1 liter bottle. So I'm just filling my bottle. So suppose say I have filled around like I have one and a half liter water with me. Okay. So I have 1 liter of bottle with me and I have 1.5 liter water to be filled. Okay. So whenever I try to fill the water, one liter bottle with water, so it's going to store until 1 liter, and then after if I try to store more than 1 liter to that, so it's going to overflow, right? So it's not going to store the 1.5 liter of water into it. Why? Because its capacity is 1 liter only. Okay. So then at that time the water is big data to water bottle. Okay. So I have 1.5 liter water need to be stored into a water bottle. So but I have a water bottle which is capacity of holding 1 liter only. So at that time I can say this 1.5 liter of water is an big data to this 1 liter bottle. So understood everyone, or it's confusing to you? Yes. So say simple manner. So I have 1.5 liter water and I have 1 liter of bottle. Okay. So a bottle which can hold 1 liter only. So whenever I try to store this 1.5 liter water into the 1 liter bottle, so it can store until 1 liter. Okay. So after that, whenever I try to store more than 1 liter to the same bottle, so it's going to overflow, right? So at that time we can say the 1 liter this 1.5 liter water is a big data to this 1 liter bottle. Okay, clear? Okay, so that's like big data, guys. So whenever someone says you, so how 1000 TB of data, so is it a big data like or not? So suppose someone asks you, so we can say, so it depends actually. So it depends on the capacity of device do you hold. So if you have more than the capacity, like suppose I have a hard disk which can hold around 1 crore TB data. So at that time, this 1000 TB data is just normal data to me, not a big data. But if the data is huge than the capacity of the device, so at that time I can say it's a big data. Okay. So next thing, so volume. So volume is one thing in big data, and one major problem here. And then next thing is veracity. Okay.
Sorry, just one question for this volume. Hello.
Sorry. Yeah.
Yeah, one question for this volume. For example, Facebook and Google, these are two giants who are basically processing on huge amount of data. So they
Okay.
already have different servers of huge capacity. So let's
Mm-hmm.
take example of Google. So Google already has the capacity to store thousands or let's say millions of GBs of data, whatever it is. So
Okay.
if Google already has that much of capacity, so will we say that the entire amount of data, the huge amount of data there by the Google, which is more than several thousands GBs or TBs, so can we still say that it is not big data because Google has that much of capacity to store that much of data, even if
Yeah.
it is more
So
than thousands of TB?
yeah, like we can say that. So even though its data is very huge, but we can able to handle that, right? So we can able to handle that. We can able to store. We can able to process it. So at that time, it's not a problem for us. So it's not a big data. So it's a normal data for them. Okay. So it doesn't depend on the quantity of data actually. Okay. So when someone says you big data, it's not about the quantity. So it's about the storage and as well as processing. Okay. So both things will
Okay.
come into picture.
Okay.
Okay. The next thing, variety. Sorry, variety of data. So we have three different data types. So like the varieties of data actually. So the first variety of data is one second, structured data. Okay, so we have one type of data as a structured data, and the second one it's semi-structured, and the third one is the unstructured data. Okay, so there are three different varieties of data. So the structured data, semi-structured data, and unstructured data. Okay, so there are three different varieties. So coming to the structured data, so the structured data is basically in the form of structures like tables. So if someone knows you Oracle, so in that the data is going to be stored in the form of tables. Okay, so RDBMS usually stores the data in the form of tables. So that data we can say it as a structured data. Okay, so structured data, the example for the structured data is the data stored in databases of RDBMSs. Okay, so that data we can say it as RDB structured data. Why? Because they are stored in tables. They have neatly organized with rows and columns. So that's very structured. Okay, and coming to the semi-structured data, we can say logs. So logs generated. So that logs is the form of semi-structured data, and XML files, JSON files. These are all semi-structured data. Okay, and coming to the unstructured data, so it's not that structured. So the images, so images are unstructured data, and next thing, videos are unstructured, and maps like that, all stuff. Okay, so all these are unstructured data, so they are not structured very well. Okay, so there are three different types of data. So it's also one problem. So we have different varieties of data, and we need to store them and we need to process them. So that's also going to be a challenge for us, right? So we have different types actually. So even if it having the same type, so it's okay, it's not a big problem for us. But we have different varieties of data. So one is semi-structured, one is structured, one is unstructured. So we have different varieties of data, and we need to handle every type of data. Okay, so that's also going to be a problem for us. So that's also going to be a challenge for us actually. Okay, and coming to the veracity. So veracity is nothing but, one second, the accuracy of data. Okay, so how accurately, so when you ask your database that I want the details of Sujay, and it's going to give you the output, so how accurately it's going to give an output is nothing but, it's called veracity. Okay, so even though we store the data, but the thing is how accurately it's going to store the data into a database. Okay, so that's also going to be one of a problem in a big data. Okay, so until this point, do you guys have any doubts? So we discussed about big data. So big data is nothing much, not about the actual amount of data, but it's going to be the capacity handling it. And we have different types of data, such structured, semi-structured, and unstructured data. So structured data are basically from RDBMSs, and semi-structured are JSON files, XML files, and log files. And coming to this unstructured data, we have images, videos, and all this stuff. Okay, any other doubts, guys, until this point, or everyone is clear with this? No, so everyone is clear, right, until this? So okay guys, we'll just move to the next thing. So the storage problems are this one, and coming to the processing problems, we have problem with velocity, and that's the only thing. So we have the problem with velocity actually. So velocity. So coming to the velocity, so velocity is nothing but speed of retrieval of data. Okay, so whereas velocity is nothing but, the definition comes in this way: the speed of retrieval of data. So how much speed you are going to get the data from the databases. Okay, so that's also going to be one of the problem. Why? Because we have very huge amount of data, but so whenever we try to retrieve one of the record from huge amount of data, so it's going to search for like in every file, right? So it's gonna huge data. We have a huge data and we need to search every entry. So in that case, it's going to be a problem for us, right? So we have huge amount of data and we need to go each and every line, and we are going to search for it. So it's going to take a lot of time. So that's also going to be one of the problem. So generally these are all the problems while we face while handling the big data things. So for this problem we have some solutions. Okay, so we're going to discuss that, don't worry. So velocity is also one of the problems. So while how much speed we are going to retrieve the data from the database, so that's also going to be a major challenge for us. But because we have got up with huge amount of data and we need some time to get the accurate results, like for this search. So it's going to take time for that. So that's also going to be one of the problem in our big data. Okay, and coming to data, so what is mean by data? So we are talking about various things about big data actually. So we jump directly into big data, but so what is basically data? So data is the collection of the raw information. Okay, so the data is a collection of raw information. So you want to collect the raw information, so it's nothing but it's a data. Okay, so like we can say that one is the data. And big data, as I already said, so if you don't have a capacity to handle that, then that's we can say that it's big data. Okay, and so coming to the facts about the data, so until 2007, so we have only the 10% data. Okay, so if the whole data present right now is 100%, so until 2007 there is only 10% of data that exists. Okay, but from 2007 to 2016, so gradually the data has improved a lot in an exponential way, and the 90% of data which are present in the right now in the current market are between from 2007 to 2016. Okay, so that huge amount of data generated in this span of 10 years. So 90% of data is generated in the previous 10 years, and like 10% of data is generated before this year. Okay, so that's the difference. So 90% of data is all generated right now, like before 10 years, and the remaining 10% are generated long back. Okay, so that's the one fact actually we need to consider it. So why? Because there is an exponential increase in the use of generation of data. Why? Because of the various technologies like IoTs or various things, like not only IoTs, cloud computing and all this stuff. So people are going to store the data very much into the cloud or in something like that. So so that's the reason. So 90% of data exists currently between 2007 to 2016, and from before 2007, so the only 10% of data that existed. Okay, so that's one fact actually we need to know about that. And so these are the, so actually we discussed about various problems which are present in the big data. So what were the solutions for that? Okay, so we discussed about problem and we need to find out the solution for that. Okay, so not only finding the question is important, but answer is also very important, right? So we have solutions for this, the problem which are for the persisting for the big data. The first solution I can give you is using the Hadoop and MapReduce or any ecosystem, Hadoop ecosystem tools. Okay, so Hadoop and something like and it's Hadoop and its ecosystem tools. Okay, the next thing, So we also have one more solution for this. The solution for this is, the one more solution is no SQL databases. So this also can be a solution for our big data problem. Okay. So one solution is Hadoop, and the next solution is like NoSQL databases. So NoSQL stands for, sorry, one second, not only SQL. Okay, so not only SQL. So there is nothing like what is the full form of the NoSQL databases? Not only SQL, we have other options as well. Okay, so that's the difference, like NoSQL databases. So we have two solutions for our big data, Hadoop and its ecosystem tools, and the next solution for this problems of the big data is nothing but it's we use NoSQL databases for that. Okay, so that's the two like solutions for our major problem. And for knowing the Hadoop, and so there we have prerequisite for this big data course. So the big data, so if you want to learn big data for sure, so we have a prerequisite, we have the first prerequisite is, sorry Manikanta, what happened? Yeah, NoSQL databases are like MongoDB, Cassandra, like that. Okay, so the prerequisite for the big data is, the first prerequisite is you need to know about SQL language. Okay, so we are going to use, we're not going to use SQL directly, but the SQL language is going to be a base for us. Okay, so if you want to write high queries or big queries or any other queries, so the SQL commands are going to be a prerequisite for us. And the next prerequisite is, so we need to know about core Java. Okay, so for writing the data in Hadoop, so we generally use MapRedis programs, and that MapRedis programs are implemented using Hadoop, so using Java. So that's the reason we need to know about Java as well. Okay, and the next thing you need to know, while if you want to learn this big data is, so you need to know something about the Linux commands. Okay, so we need to know about all this stuff. So we need to know about SQL languages queries, how to write an SQL queries. And the next thing we need to know about this core Java. And the next thing we need to know about this Linux commands. Okay. So all these things will come together and you're going to learn big data on a whole. Okay. So we are going to like install our VMware software into our systems. I'm going to share the Google Drive link soon, and you need to download that image of this VR, like a virtual image, and you need to use something called as VMware or something like that in order to use the Linux OS in your systems. Okay. So otherwise, you can also make sure that you can remove Windows from your system and you can able to install Linux onto it. Okay, so the both things work actually. So VMware and all this Linux, direct installation of Linux also works. So that's a major prerequisite for our the course. So core Java, SQL, and as well as the Linux commands. So these things are very much important if you want to start the course. I guess we have completed SQL language using Oracle. So you can also find the videos of Oracle in our YouTube channel, and you can access them. And for core Java, I'm going to take around something called 10 to 12 classes for that. So if you are interested, you can join, or if you already know the core Java, so then you can directly attend our big data classes. And next thing, so basically the Hadoop is actually working in Linux environment right now in the real-time scenario. So for that reason, we need to know about Linux commands so that we can access that Hadoop ecosystem rules and all this stuff very easily. So for that, so we need to know the Linux commands for sure. Okay, so these are all the prerequisites for this course, and you need to just complete all these things in order to understand a better big data course. Okay, so that's about the prerequisites, and so it's going to be taking around 45 days for us if we want to complete these big data things. So it's gonna be alternate days. So the first day will be R, next day will be Hadoop, and next day will be R, next day will be Hadoop, like that. So alternate days it goes. So if you are not interested in learning Hadoop and all these big data tools, you can just skip. Or if you are not interested in learning the machine learning or like Python and R programming language, you are always open for skipping that. So some people join this course for big data, and some people join it for data science. So no issues. So it's your requirement actually, and it's your wish. So you can do it anyway. And the next thing, so when coming to the stats about the data, so can anyone tell me, so how much data that Bahubali film took in order to produce that kind of quality? So anyone can guess? 50 GB? Oh, so the HD quality of Bahubali is going to be 50 GB. That's it. But for generating that visual experience to us, so can you guess how much of data it has taken? 10,000 TB? No, nobody. Not correct. So do you know, like, do you watch that? Did you watch that film? No idea. Okay, no issues. 50 TB. Okay. So actually, it's going to. So it's going to take around 150 PB. Okay. So 150 plus PB for generating this Bahubali film. Okay. So Bahubali took around 150 plus GB, 150 plus PB data for generating that visual experience for us. And so, do you know how much data that Google generates on a daily basis? Anyone can guess that? The Google is going to like generate almost per day. It's going to generate around, not in TBs, so it's going to generate around 40 to 50 PB. Okay, so 40 to 50 PB of data are going to be generated by Google. Okay. So next thing, so do you know, so what is the like fastest RAM present right now, and what is so do you guys guess what is that thing, like what is the highest speed of RAM right now they are using, like what is the highest capacity of RAM they are using right now in the market? Anyone?
No idea. Maybe 10 TB. Just a random guess.
10 TB. Okay. Nice, buddy. So we have 1 TB of RAM. Okay. So we right now in the current market we have 1 TB of RAM, which we are using for by SAP HANA. Okay. So SAP HANA is a database, so which are used for the like what we say, like stock market. Okay. So the stock markets, so it's gonna like huge amount of things. So it's gonna take around 1 TB of RAM. Okay. So that's about the stats, guys. So that's about the big data today. So do you have any doubts, guys? Until like this is about the end of the class. So we discussed about what is big data, what are the problems, what are the solutions, and so what are the prerequisites for the big data. So guys, if you have any doubts, you can ask me.
Yeah, I actually didn't understand this 10% 2007 and the other percentage you mentioned about the data, that part. And second is that veracity. So these two things I haven't understood properly.
So veracity is nothing but the accuracy of data. So how much accurately we are going to store the data in the database. So we have huge amount of data, right? So
Right.
how much accurately we are going to store the data is nothing but veracity. And next thing, So generally until 2007. So like from previous years, from BCs, suppose say BCs to 2007. So we have generated almost about 10% of data which are present right now. Okay. So suppose say the whole data presently is 100%. So from BCs 2007 we have generated 10% data, but from 2007 to 2016 alone we have generated the 90% of data. So because of these IoTs and all this stuff. Okay.
So this data, it is in terms of what exactly you're talking in general. I mean, the data which is present in the world, human data.
Suppose say like if the whole data is 100%, the 10% data was generated between BCs to 2007, like before 2007, and from 2007 to 2016 we have generated around 90% of data. Okay, so that's very huge. So in 10 years span we have generated 90% of data actually right now present in the market. Okay.
Yeah, got it.
Got it? Any other doubt, guys? So like after getting the output, so it's gonna be 2 GB. So after compression and all that stuff, but so for generating that 2 GB of data, so it took 150 PB of data. Okay, so like for generating all that stuff and for creating this output, so for creating that clarity output, it's like it took 150 PB. Okay, so that's internally what happened, I said, not the actual cinema, the actual output. So the exe will be around like generally if you say, so if the whole software is going to take around 2 GB, the output of that software is going to be around 2 MB. Okay, so that's the thing. The whole thing, it took around 150 PB of data in order to generate that visual experience, but that 2 GB is the output for this 150 PB. Okay, clear? Generating 40 to 50 PB of data daily. Okay, 40 to 50 PBs. Okay. Any other doubts, guys? So fine. So if we don't have any doubts, we'll just quit the class. So no. Okay. So fine, guys. Thanks for attending.
discuss